Well, we're back to some, can there be current events in creation? I mean, creation goes way back to the book of Genesis. That's old, but there are current events. And we're just going to look at some questions that you might have wondered about and kind of fun to look at. There's lots of questions. We don't have all the answers, but we'll have a go at it. Just to get started on this, maybe it's quiz time here this time of the afternoon. I got a few space pictures. Can you identify them? What are we looking at? Well, I think I hear the answer here. This is Sputnik, 1957, the very first artificial satellite. Time goes by, the beginning of the space age. This thing frightened Americans because the Russians beat us into space, and there was a Cold War going on back then. And you could see this thing go right over the country, and we couldn't do anything about it. But soon enough, we started to put up our own satellites, and the race was on. How about another unknown? What are we looking at? The International Space Station, there it is. They keep building on this thing larger and larger. It's up in space right now. There are people on board. Not sure what they're doing, trying to stay alive, I guess. Kind of controversial, people in space, but it's part of our whole progress. And there it is. You can Google the space station and see when it's going to go overhead, and you can, go out at night and watch it. It's just looks like an airplane, but it doesn't blink. It's collecting the sunlight as it goes by. Hey, we're doing just a little identification in this space area. My goodness, that's too complicated for a Saturday afternoon. What are we looking at? This is kind of a big setup. Can you find the person in this picture? I think there's somebody there. Here he is, right here. He's actually in a tunnel that's deep underground, and this is the biggest experiment in the world right now. It's over in Europe, and what they're searching for is called the God particle. You might have seen this in the news. I'm not sure I like that title, but in this experiment, they get protons going real fast in two different directions in a big circular tunnel deep underground, protons almost up the speed of light, and then they bang them into each other, and they're going to see what kind of shredded materials come off. And what they're looking for is the basic building block of matter. It's pretty fundamental research, and it takes a big experiment like this to do it. This employs 10,000 scientists. It's multi-billions of dollars, all to find out what matter is made out of. And they kind of named the basic one that they're looking for the God particle. Now, I don't know if they'll find it or not, but if they do, I have a prediction. It's not the end. Because if you could build a bigger atom smasher, you could crack that thing in half and see what's inside of it. You know, you can split an atom and get protons. You can split a proton and maybe get something else. It's like taking the layers off an onion. It just goes down and down. Creation is like that. There are probably endless layers inside an atom, things we have never seen. Just like space goes on, so does the internals of an atom. We were talking this morning about design, in nature. I wonder about all the design on that deep, deep level that we can't even see. It's just there if we ever get there. Well, you did well on that little quiz there, some unknowns. What we're going to do is look at a few questions that you might have wondered about in this whole arena of space. I think I got about 12 questions if we got time for them. So we'll take the first one here. And why not just start with a fundamental one? How about it? Was there a Big Bang? We've all kind of grown up with this theory. It's just been around. And what is the story? That long ago the whole universe was just this big? No, it was smaller than that. It was a mathematical point. The whole universe, some sort of little nugget. And one day it became unstable and started to expand and move outward. And from that, gas formed, and then dust, and then galaxies and stars and planets and people all spinning out of this expansion. It's quite a story, isn't it? You believe all that I just said? The Big Bang Theory. Well, it does make a good story. And actually, a lot of people who are in the Christian faith, they think that must be true. Somehow we need to fit that into the book of Genesis. But thinking about creation, it's far different. In fact, here's a creation verse over in Psalm 33:9. For God spoke and it was done. He commanded and it stood fast. That does not sound like some sort of slow, gradual, spontaneous, accidental expansion. It sounds supernatural that when God spoke, it was done and it happened quickly. I can't match that up with the Big Bang. We're not sure how God did it. I mean, the creation week is holy ground. But any of our man-made theories, like the Big Bang, got to be wrong by definition because we can't explain the supernatural. And thinking about this, by the way, got a little bit of Latin at the bottom there, ex nihilo, which means from nothing. When God created, it was the work of his fingers. He just spoke things into existence. Some of you guys are creative. You can do photography, landscaping, or whatever, but we always use some kind of beginning materials. God just started nada with nothing, and there it was. Only God really creates. So that's kind of where I stand. At least there was not a Big Bang as usually described. If you want to say God spoke and bang, there it was, okay. But it's more, the whole creation week. And if you look more closely, the order in Scripture that we take very seriously, the earth is here before the sun, moon, and stars. Earth on day 1, the sun and stars till day 4. The Big Bang doesn't do that. The Big Bang puts the earth off to the very end. I'm sticking with creation. It makes good sense. It's a refreshing alternative to this Big Bang stuff. I've noticed something about these theories. They don't last very long. Before the Big Bang, it was the steady state theory. After the Big Bang, it'll probably be multiple universes or some other choice. Scripture is so refreshing, not changing, and it's our guide. We're looking at a few questions in this whole area of astronomy and space. Let's go on to another one here. Is the universe getting larger and larger? Does it take you longer to get to work? Now really, is it expanding? It seems like it. Now this is often taken, as an evidence for the Big Bang. To say, well, the universe was smaller a year ago, smaller yet 1,000 years ago, and if you go far enough back, you're back to that nugget again. But let me answer this question. As far as we can tell, yes, the universe is expanding and getting larger every day. Not the Earth, not the solar system, not even the Milky Way. This is deep space stuff that distant galaxies seem to be spreading out. We get this by studying the light from these far-off objects, something called the redshift, and there are other interpretations, but it seems to be the one that makes the most sense. I would suggest that this universe was made large and getting larger, that it was created in an expanding mode. And to extrapolate that way back to a beginning nugget, I think that's an unfair extrapolation. It was made big and getting bigger. And I think there's reasons for that. What if the Creator made this whole universe and took all of these galaxies and everything and just parked them out there static so they were sitting still? Well, you know what would happen? Gravity is everywhere, and it would take over, and everything would start to fall in together. We would get the big crunch, I guess. That wouldn't be good. It would be an unstable universe, realizing that it's all going to crash together. This expanding situation gives stability to the universe. I'm just suggesting that may be of why God put it together that way. Actually, there are lots of motions in space. Right now we're moving. Here on Earth, we're on a merry-go-round turning, and here at this latitude, we're moving at about 800 miles an hour. Right now. You say, I am not. I'm sitting in this chair. I can't feel the wind. It's a good thing, because the atmosphere, the birds, everything goes right with us. You don't notice that turning motion in space. Due to our orbit around the sun, we're moving faster, about 60,000 miles an hour. Right now. There's more, because the whole solar system's moving. In fact, the whole galaxy's turning, and you get up to be over 1 million miles per hour that we're moving right now. I can see you're skeptical, and it's a good thing we don't even notice it. It's just God's care, but you have to have all these motions for a stable universe. I mean, if we're not orbiting the sun at high speed, we'll fall into it because gravity just keeps acting. So anyway, that was my quick answer there. I think the universe may well be expanding, not at all a proof of the Big Bang, but of a stable universe that was made for us. We're looking at some questions in this whole area of space and astronomy, and after the Big Bang and this thing, let's go on. Trying to get some basic ones here you might have wondered about. Now, do you notice who's in the saucer there, by the way? Are there aliens? Is there life in space? What a question that is. I know they make movies about all this kind of thing, and we seem to keep reading about looking for other planets and life in space, and let's just explore this for a minute. A few centuries ago, it wasn't realized how complex life is. It was thought that if you had some mud, that maybe those molecules would come together and life would develop. It was just thought rather simple. In fact, I found an early formula for how you can make mice. Here it is, out of the recipe file. It was thought, take some grain and moist rags, put them in the corner of your room for a week, and mice will appear. Now I should say, kids, don't try this at home. It might work. You know, mice, they always have scouts around looking for a nesting area. And if they can get in, if you have rags and food, they'll show up. But, you know, this was disproved, this idea, by Louis Pasteur, who took the materials and he put them in a sealed container. And if no mice could get at them, then the material breaks down, it just spoils, deteriorates. Don't we know that mice come from mice? And so it has ever been. Interesting formula from the past. Now, they've done lots of experiments trying to get life to originate in the lab, and you know some of these experiments, like with Stanley Miller and such, and they all fall flat. The origin of life remains a mystery, and because of that, in the science world, they're looking elsewhere in space. Like we've been sending all these probes to Mars. No people on Mars or Venus or elsewhere, but a lot of remote craft. And on Mars, there's several up there right now. It's part of our space program. I enjoy all the neat pictures they get. But what are they doing up there? They have these robotic craft on Mars, and they are rolling around. They're like the size of a golf cart, and they're taking pictures and drilling holes in the rocks. What are they looking for up there? Right, they're looking for Martians. There's this assumption that life will evolve, and if it happened on Earth, it should happen elsewhere, and they just keep looking, and they don't seem to find it. Now, that formula for mice I got right there, I'm thinking, I'm still seeing that formula in our modern day. If you read the articles in the newspaper, often these articles end up talking about life, and here's the assumption that if you can find another planet, and they are finding new planets going around other stars, and hopefully then maybe there's some water there, and if there's some sort of sunshine energy and you let enough time go by, then life will show up. That always seems to be the end of these articles. And I want to say, nice try, but this formula just doesn't work. Life is not that simple. You don't just add water to get it. You've seen before the idea of a living cell and how complex it is. There's a whole world in there, and it goes on and on. We don't know the half of it. The formulas haven't changed much. Hopeful, but it doesn't go. In fact, you know what astronomers are saying these days? Where is everybody? It looks more and more like we're unique. And that answer to that question, as far as we know, there's no life in space. After 50 years of the space age, not a shred of evidence of life anywhere else. It appears that God's put lots of life on the earth, but chose not to do it elsewhere. And so the days go by. A little bit more on this life in space that's kind of interesting. This might be a little technical for a Saturday afternoon, but there's a guy by the name of Frank Drake. And he's an astronomer. He had a whole career at Cornell. He worked with Carl Sagan. He's retired, but he's still around. And he thought, well, if we can't find life, I'll just calculate how much life there is in space. And so he's got the Drake equation. And let me just kind of walk through this with you. N, the number of planets in our Milky Way galaxy that have evolved life on them. He's written a whole book on this. I mean, quite imaginative. There's a bunch of little letters there that kind of spell things out. Here, let me just do those myself. Boy, if you want these notes, I can give you this sheet later that has all these. But here's his calculation. Little n is going to be the number of stars in the Milky Way. We can estimate that. F sub p is the fraction of those stars that have planets. That's a very active area, looking for other planets these days. They're up to about 1,000 new planets going around other stars. Fraction of stars with planets. The next F is another fraction. The fraction of those planets that would be Earth-like, because it's got to be a planet that's solid, that you can walk on it. It's got to have some oxygen. It's got to have some water, so like Earth-like. And the last fraction is the fraction of those Earth-like planets where life has evolved. Now, he's got a few more terms, but this is a simplified form. Let's try this out. Let's put some numbers in this formula, and let's calculate how many planets have evolved life on them in the Milky Way. What do you think the answer is going to be? Let me show you the numbers they typically come up with. Little n, the number of stars in the Milky Way, 100 billion. That's 10 to the 11th. That's clearly rounded off. It's an estimate. The sun is just one of those, but who's going to argue with that? That's a typical galaxy, 100 billion stars. The fraction of those stars that have planets, just to be conservative, take 10%, 0.1. 1 out of 10 of those stars have planets. A planet is just an object circling a star. The fraction of those planets that are Earth-like, small enough to have some gravity so something could survive, let's put in 0.1 again. Now comes the tough one. The fraction of all this where life has evolved, they're very optimistic. And they typically put in unity, the number 1. Because if things are set up, the assumption life is going to show up given enough time. And so here's our answer: 1 billion inhabited planets in the Milky Way. A rather lofty number. And that's where they write the books on this kind of thing, without a lot of data, but using their numbers. Now, again, it is kind of, afternoon and all this, but can anybody challenge this? Do you see anything that looks a little suspicious? What would you go after? Can someone help us out here? Anyone want to correct this? Yes, what do you say? You don't like the billion? I don't either. Which one of those assumptions do you kind of challenge? Yes? That last number, evolved life, that does sound a little suspicious, and that's what you're going to say as well, right? Let me modify this a minute here. Am I being biased or what? All of our research shows that the probability of things evolving on itself is nada, 0. So I'm going to change that to a 0, and then the other numbers don't even matter. Because if you put a 0 in this multiplication thing, you end up with nothing. And I think this is closer to the truth, even though Frank Drake wouldn't go with it. That's how it comes out. These are planets with evolved life. We don't find any, even though they're so hopeful with this. Now, whether the Lord has chosen to put some other life way out there or not, I don't think so. But if there is, at least it didn't evolve. Scripture is very clear, that God treated the earth special. The Lord walked here. Scripture says the earth was made to be inhabited, whereas all the stars show God's glory. It looks more and more like we are unique. Anyway, that's where that equation went. I think it's closer to 0, at least for evolved life. The Drake equation. Interesting. Hey, we're looking at some areas of space study, so let's do some more here. And in fact, let me get closer to home. Let's think about the moon for a while. That is our nearest neighbor, and we all get a good look at it as it goes through its phases, and there's several things about the moon we could react to. First of all, have we been able to figure out from a natural viewpoint how the moon got to be circling our Earth? Now, I think the Scripture says God put it there, but this is our modern scientific age, and we need to have our own explanations. So, do we know the origin of the moon? Over the years, there's been different theories, and this is one of the reasons for all the moon research in the Apollo program. Let me survey some of these with you. What do we have here? What do you see in that picture? A bowling pin? A chicken drumstick? What is this? Now, back in the 1960s, the 60s, this was the theory, the origin theory that was in all the books. Now, this is pre-internet, so it was in the astronomy books. And the suggestion was that a long time ago, before anybody was on the Earth yet, the Earth was young and it was molten and it was spinning a lot faster than today. Instead of 24 hours, it was like 2 hours. And it was going so fast that a bunch of material kind of stretched out and broke off to make the moon, fissioned off. That'd be exciting to stand back and watch that happen, the fission theory. Well, this idea went away in 1969. That's one of those points in history. Neil Armstrong and friends walked on the moon. And by the way, we did go to the moon. They brought rocks back to the Earth that are still being studied today. And the minerals in moon rocks, they're different than Earth rocks. I mean, the ratios, the quantities, just enough that it does not look like the moon came from here. And it was such a neat theory. And in fact, there's other problems with this fission theory. if the moon broke off from the Earth on the way out, it would have been close to the Earth and our gravity would have just fractured it into pieces. They call that within the Roche limit. And we wouldn't have a moon, we would have a ring like Saturn has. Just mentioned two problems with fission. The rocks are different and it wouldn't have survived the trip. Anyway, after the fission theory, the next one came along and it was called the capture theory, the 1970s. And this was in all the books. And the story was that long ago, the moon just came here from somewhere else, so live with it. And it came swooping in close to the Earth, and we reached out with our gravity and captured it, and it's been circling us ever since. It's not really an origin theory, but we'll give them that. So there's the picture. As before, there's two problems this time. There's always these fatal flaws with these theories. One trouble with this one, and if you can imagine, if the moon would come close to the Earth, it would feel our gravity, and it would go around that outside curve. But after about a half a trip, it would pick up speed and just take off out of there, like crack the whip. Now, to get it to stay in orbit, you'd have to slow it down, put on the brakes, insert it into orbit. And how do you do that with these natural origin theories? So that was a tough one, and it just didn't go very, very well at all. So the capture theory was on hard times. Another trouble with this theory is if the moon would do that, even if it would get captured, it would be kind of a lopsided orbit. But actually, the moon's orbit is almost perfectly circular. It does a pretty nice job. Moves in and out a little bit, but not all that much. It looks just too good to be captured by chance. We had fission, we had capture. There's more. Because the next decade comes along, and the nebula theory was in popular newspapers. Now, the thought this time is that the Earth and the moon started as two smudges. You see them there? Those are supposed to be clouds of dust and gas. That's what a nebula is. In fact, there's still a lot of that stuff in space. We can look at it with telescopes. We couldn't last night. There were just too many parking lot lights, but they're up there. And you know what almost all of these clouds of gas are doing? If I could just picture a cloud, they're getting bigger. They're expanding because there's outward gas forces. You know, a balloon wants to pop. Now, if you get them small enough, like the sun, which is gaseous, it'll stay small. But how do you kind of squeeze these things down to a solid Earth and moon? It doesn't work. That's the trouble with the nebula theory. The forces are in the wrong direction. So there went another one. And that's the main problem. It just, gases expand. Let me move on to the moon origin theory that you'd look if you would Google this today, and it's in all the books. Since nothing else works, they're really thinking catastrophes. So the present view is that something came down and smashed into the Earth. Looks like a big asteroid or the nucleus of a comet. This thing is said to be the size of Mars, and it strikes the Earth so hard that it breaks the Earth into pieces. And some of the fragments fly up into the sky and they coalesce together to make the moon, and the rest of the Earth tumbles back together. They don't have those details figured out yet, but I'm just telling you what they say. And so there it was. Now, this theory is relatively new, and the problems need yet to be figured out, but I've seen the trend that it won't last too long. Actually, two things have happened with this theory to shoot it down. Some of the models of this say that we should end up with two moons. The fragments would go two different ways, but nope, we've only got one moon. And just last month, NASA studies have shown that there are some water molecules on the moon, not lakes and rivers, but just stray water molecules in the rocks, and there's too many. If you would have this kind of collision, it would have burned off all the water on the moon, and there is some there, so that goes away as well. Well, what's coming next after these origin theories? I've been in this for a while, watching this stuff, and the trend is these theories roll on by. Each one lasts about 10 years, give or take, and then the next one comes along, and that makes a person humbly want to speak up sometimes and say, maybe we can't explain the moon. Maybe somebody put it there. Maybe it was created. Now, I don't know if that sounds scientific, but it makes as much sense as these temporary fallible theories do. And so I'm thinking of a created moon. And one thing I like about this whole creation viewpoint that we're pushing this weekend together, as soon as you say God put the moon in the sky, there's reasons for it. It's not a chance or an accident. So thinking about the moon, what's it good for? Does it do anything for you? Would you miss the moon if it was gone? Now, really. You think of the tides, you think of moonlight, but that turns out to be just the beginning. Actually, I was given this talk somewhere, and I mentioned the moonlight, and a critic said, "We don't need that moonlight. We've got flashlights." That's what he said. And I thought, can't you do any better than that? Yes, we have street lights and flashlights, but for a lot of people on this planet, that moonlight is important. And it may be more important to agriculture, to germination and things that we realize. But anyway, I started a trial list here of things that the moon does for us. By the way, even though this collision thing is kind of temporary, they draw these neat pictures. That's supposed to be the object hitting the Earth. That's some kind of explosion. But anyway, onto the moon and its purposes. Again, this list would, I think, just be kind of a beginning. The moon does this and more. It is a night light. Some nights a full moon, some nights a crescent moon. You can tell time by the moon if you get into these phases. You can tell the season. You can tell the direction. The moon is so faithful. We've learned in just the last 20 years that the moon is why we have our seasons. Now, of course, the Earth is tilted. You remember that? 23.5 degrees, like a globe in the classroom. That's really what does our seasons. Studies have shown that without the moon, the Earth's axis would wobble. We might go from summer to hotter summer. You'd never know what was coming next. Thank you, Lord, for these faithful seasons. There's the tides. That's gravity, not too well understood, but back and forth the water goes worldwide, scrubbing the shorelines. And then I put one more word at the end, life. And by that, I mean your life and mine. Because those tides keep the ocean healthy. And there's incredible life in the ocean. Since this planet is 3/4 covered with water, there's lots of critters in the ocean. There's lots of plants, aren't there? There are floating plants. There are kelp forests in the shallow areas. Lots of plants. Now remember what plants do, how they breathe the opposite of us? They take in CO2 and they give off oxygen. Current estimates are that sea plants make half of our oxygen in our atmosphere. What if there was no moon? No tides, which are a major component of the ocean currents. Without the tides, computer programs show that the ocean would die. It would become stagnant. You wouldn't want to go to the shoreline anymore. And all the plants would die. No moon, no tides, no plants, no oxygen, no us. I think our very breath is dependent on the health of this whole situation. Now, this world is no longer perfect. We've had the fall, the curse, and you can still see in a way how this is put together for our survival and well-being. I look at this list and I think, how much do we not know about the moon yet? This gets very intricate, and there's things we're still learning. The moon is precious. There's still more we could say about the moon. We're going through, I think I have like 12 little questions altogether to answer when it comes to space. Some of these get a little technical, but let me try this one, because you might have heard of it before. Is lunar recession an age indicator? And where am I getting questions like this from? Now, this is the idea that the moon is actually getting further away from the Earth every year. Have you noticed it getting smaller in the sky? You say, I don't think so, Young. No, it only changes by about 2 inches a year at present. But it's called recession. This is a tide connection. Actually, it's slowing down the Earth, and the moon is being slung further and further out at a very slow scale. A couple inches a year, but that means in 10 years, 20 inches, in 100 years, in 1,000 years, this adds up. Furthermore, this recession, which is part of gravity, and it goes on and we can measure it, it's not linear. It's not always 2 inches a year. In fact, if you're into math, this next one kind of shows how dependent it is. It depends on the 6th power of the distance, which is a huge multiplication. Another way to say this, if the moon was only half as far away from us as it is, this recession would be 64 times greater, 2 to the 6th power. Anyway, if you do all the math on this, you find out that if you go back in time, the moon would have been very close to the Earth in about 1.5 billion years. In fact, it'd be right here. It'd be right up against your nose. Hello, moon, because you see it's moving out from us right now. Well, now that's interesting, and it's not obvious from the math. You'd have to do this the way it's increased in the past. What did I say? 1.5 billion years? You see, you can't do that, because if the moon is anywhere near the Earth, it would be broken up into pieces. And yet, how old did they say the moon is? 4.6 billion years, the same as the Earth. There's some fundamental problem here with deep time. The moon can't even be 1 billion years old, let alone 4.6. I think this recession is some kind of an argument that there are problems with deep time, with evolutionary time. Now, don't get me wrong. I'm not saying that the moon is 1 billion years old. I'm just saying it can't be anywhere near that, let alone 4 times that. I have not heard a good refutation of this idea, because we all can measure from the things that were left up there the way the moon is moving out from us. There's a whole technical article on this, by the way, and I could get you the reference if you want to do more looking at that. We're thinking about the moon right now, and let me do something else with the moon. After all, it is our nearest neighbor, and it's kind of important to us. Our question number 6. Are there in people time, historic time, records of large craters forming on the moon? Now, you've looked at the moon perhaps before with binoculars or a telescope, and you got all those craters up there, and it just seems so quiet. The moon always kind of looks like a museum. You know, it just is there. So this is an interesting question. And from the pictures going along, the answer here is yes. There are historic impacts. In fact, if I could just read about one here. Now, this is a while back. It's about 800 years ago, if you look at the AD year. And there are records from back then. And this is from Europe, where some people noticed something interesting on the moon. Here's what they wrote. It must have been a crescent moon this night in June, AD 1178. We saw the upper horn of the moon split, and from the division, fire and hot coals and sparks spewed out. The phenomena was repeated a dozen times or more. The moon took on a blackish appearance. Boy, how'd you like to be looking at the moon when it seems to be blowing up? That's pretty exciting stuff, and this is in diaries of people back then. What they were looking at are great clouds of gas and dust which were rising from the surface of the moon and kind of hiding its light. You might call this fire on the moon. What they were witnessing was a large impact on the moon, that they still do happen. Now, here's how I can tie this with our creation weekend. The common view for the moon is that all the craters we see are ancient, that they happened early in history, at least 4 billion years ago. It's thought that nothing happens on the moon anymore. And if you ask an astronomer about this, they would estimate, well, maybe you get a new crater every 1,000,000 years. I keep hearing that number, which means, you know, about never. But you see here, if this is true, a record of an impact, a crater, only 800 years ago. Let's see, 1,000,000 years, 800 years, very unlikely. And astronomers just can't accept this idea that somebody saw this. It's like in 1,000 years instead of 1,000,000 years. It's one chance in 1,000. You can't see it, but they did see it, and they recorded this. They happened to be looking at that very time. And even though astronomers don't believe this, you can see it up there. Now, here's a full moon, and you'll recognize some of the markings. There's those seas, those lava flows, and I marked what's called marcresium. Maybe you recall seeing this. It's just with the unaided eye, and it's right that little patch in the upper right. Actually, where we think this explosion was seen is just around the back side. It wasn't on the front, but just around the edge, just to the right of marcresium. And some of our spacecraft, like the Clementine, have gone around the other side and taken pictures, and you can see this very fresh blemish. And we think that's the one that these people saw back in medieval times. That does look like a fresh crater. They call it Crater Bruno, named after a theologian from the past. And when they look at this thing close, they can even see where landslides have occurred recently. There is some activity on the moon. It hasn't been dead and quiet for a 1,000,000 years. Things are still happening. So there it is. This crater is about 13 miles in diameter. So there are some bigger, some smaller, but that's still going on. I think I have a creationist prediction. I don't get into all these millions of years. And this was seen here by people. I would predict that maybe in the next couple hundred years, we'll see another major impact on the moon. This stuff isn't all swept under the rug in 1,000,000 years ago. It's still going on. There still is some debris somehow left over from the creation, and it still smacks the moon now and then. I don't know if you followed all that, but I'm going on, and I'm still on the moon, so here's another question. These eclipses that occur, you know, when the moon gets in front of the sun or vice versa, they're kind of neat. We've all seen one before. And so the thought here, just to kind of get practical for a minute, when's the next one? Now, here's a lunar eclipse when the moon moves through the Earth's shadow, and it doesn't disappear, but it kind of turns that red-brown color. This lasts for a couple of hours. It happens once or twice a year when there's a full moon. That ought to happen in October, you know, to go along with things. I forget when the next one is, but it's not all that rare. But the other kind of eclipse, when the moon covers up the sun, that's a little more interesting because that happens during the daytime, and doesn't show that too clear through the palm trees, but that's the sun with a bite out of it because the moon is in the way, and the moon doesn't have any light, so you don't see it, but there's part of the sun that's gone. And even more dramatic is on occasion where the sun gets completely covered, a total eclipse of the sun. That's kind of rare. I've never seen one. But just to be the first ones to know here, there are some interesting times coming up. These blue paths show total eclipses that are going to sweep across North America over the following decades. In fact, we got a big one coming up in 2017. What is that, 6 years from now? And that's just one of those blue lines. Oh, it's missing Washington, but it's just south of us there, and it goes right across the country. And if you're on that path, a total eclipse, dark in the middle of the day, the stars will come out, and it'll last for, just a few minutes when that happens. And when it does happen, they come in pairs. So there's another one in 2024. Some of us are just going to try to hang on here for a while so we can see this before we leave this planet. And at a given place, on the average, about once every 400 years. So this is a special time we have coming up where we're going to have these coming across North America. You'll hear a lot more about this. People are going to be buying telescopes, and you'll be the first ones to know. Now, it can be cloudy when that happens, and then you miss it. So then you have to charter an airplane to get above the clouds. But we got some neat times coming for these total eclipses. Now, the whole thing is kind of strange. How is it that the moon can cover the sun completely? I mean, the moon is a lot smaller than the sun, 400 times smaller. But as you know, it's also 400 times closer. And so that the moon and the sun appear to be the same size in the sky. What are they, the size of a quarter? And they can just cover each other up. And I think God did that just so we can enjoy eclipses. In fact, there's nothing else in the solar system that has this perfect match in distance and size to make these eclipses possible. So there we go. Let's make sure we get together for another conference in 2017, and we'll take a look at that eclipse together. Fun times coming. Well, again, I'm just going through a few questions in astronomy, and I hope this is of interest to us. It's a grand part of creation. Last night, Chris gave us a great show on the depth of space and kind of some neat graphics. Let me look at that again, but even make it a little simpler in case those numbers were too much for me. Let me get real basic here for a minute. And this thing called a light year. I mean, what is it? Yeah, there's Buzz Lightyear. We need something like that on a Saturday afternoon. But this term, it's not very well named because it sounds like a time, but as you know, it's a distance. It's kind of like a measurement stick called a light year, and it's a big distance. It's defined as the distance that light would travel in a year. And if you want to get the numbers for it, it's like 6 followed by 12 zeros, 6 trillion miles. That's rounded off a little bit. But that's about how far light would go in a whole year if it doesn't bump into anything, a light year. And that's one of the basic measurements that we use in astronomy. And then we talk about, give or take, lots of light years. And it's kind of handy that way. Space does have those kind of distances. And just to kind of compare that for a minute, I was picking out a few different objects. The moon, not a whole light year away. In fact, 1.3 light seconds away. The sun, about 8 light minutes away. That means when a little puff of light leaves the sun, it takes about 8 minutes to get here, traveling lickety-split like it does. The Big Dipper stars average about 100 light years away, some a little more, some a little less. So you go out at night and you look at the Big Dipper and just think, that light's been traveling since 1911, and it gets here in 2011. Within reason, there's some history to looking back in time when it comes to the space. And then the distant stars, actually galaxies that they're part of, is where you get into the thousands of light years and millions and billions, and on it goes. And this again was what Chris was telling us about last night. I have the feeling that this universe is much larger than anybody's dreamed. Not just billions of light years, but endless trillions of light years. I don't think we've seen anything. That fourth day when God made the sun, moon, and stars, that was one grand day, and that's what creation is like. Well, it didn't tire God out. He just flung it out there from his infinite energy supply. But we are just beginning to explore this whole thing. And by the way, talking about all these numbers, we got to have one more big one here. Well, I guess we'll go right to this one, which is a basic question in this whole topic of Bible and science. If those stars really are that far away, and the universe is not all that old, we've kind of been suggesting that this weekend, how can we see those stars? How do you see distant starlight? This question just comes up and we all think about it. There are different approaches to this, different possibilities. So in case you are wondering about this, let me just kind of go through a few possibilities. The first one I'm going to X out. Some have suggested that maybe those stars are not as far away as we think. That they're like little Christmas lights. They're not that far up there. And the light can get here in a hurry. I'm sorry, that one's disqualified. The stars really are a long ways away. And like I just suggested, some of them are probably further away than we have imagined. Some have suggested that light speed has changed, that it's been sort of an exponential decay. And let's say back in Old Testament times it could travel faster, and it kind of slowed down to the current speed, so that's how far away light could get here. Can you follow that one? I gave that a question mark. There's not good data for that, but then again, we don't know what the speed of light was 1,000 years or further longer ago, so I doubt it, but I put a question mark on it. It's still being studied by some creation scientists. Could it be that there are different clocks? Now, these are ideas popularized by Russ Humphreys and John Hartnett, modern-day creationist astronomers. And they're deep thinkers, and they write technical books. They're out there in the book table. They say things like, while 6 days are going on planet Earth, there are billions of years going on in space. And time is somewhat flexible. We've been studying time, and it's somewhat stretchable. Time can be stretched like a rubber band or compressed together. Don't some hours seem longer than others? Be careful. Because that's not really what I mean here. It's not in your mind. But within reason, time is an interesting variable, and it's not as rigid as we think. And so what these gentlemen are proposing is that due to relativity and cosmology and gravity, while 6 literal creation days are going on Earth, lots of time in space, so there was time for that light to get here. That's still being worked on. It's interesting. Jason Lyle from AIG proposes a privileged reference frame. He suggests that any light coming toward us travels instant. It has infinite speed. From a star to here takes no time at all. And you can do that mathematically. I think it's kind of artificial, and there's really no good way to, I don't think you can check these ideas, but I've been watching this stuff, and every year there's the next idea. They seem to come and go. Can I propose a last one here? And maybe this is showing my age. But the idea that God just made it that way, that when He made the stars, He made them with their light thoroughly spread out. The idea of a fully functioning, mature creation. Now, there are challenges with that. So then if you look at those distant stars, are they really there? Or are you just looking at light that was made in transit? I don't know. But any one of these theories has unanswered questions. And I just have watched those technical ideas. There's a new one every year, and they're fun to study, and they capture the interest of us. But the mature creation idea, it stays around. And these things get revived, and the more I think about this, the more I favor that. You know, when sunlight comes to us, we think that sun is made in the core of the sun. Those are photons. And by our present understanding, it takes those photons about 20,000 years to get out of the sun, just because of all the collisions. Well, we get sunlight. This light that we had yesterday, is that coming from the core of the sun, or was it made halfway out here? Again, I think creation was made fully functioning, mature, with that light on the way here. I'm going to leave that topic. But anyway, there are some choices, and I don't know what they'll come up with next, but I get a little bit I feel a little uncertain of these ideas where we try to explain seeing distant starlight with our present-day physics, and we know so very little. So I'm sorry I didn't do the greatest job on that question, but I'm moving on. How many stars are there that we have actually photographed? Well, there's a whole bunch of them. Should we count them? And those colors have to do with the different temperatures that the stars have, and it kind of makes a neat picture. Well, let me just give you the number in case you're taking notes. It's 1 followed by 22 zeros, the number of known stars, and it's probably the first drop in the bucket, but that's what we have. Just it goes on and on. We could divide those up, one for you, one for me, one for everybody on Earth. You'd have over 1 trillion stars. We'd all be wealthy, but they're not ours. What a story that is. I am running out of questions here. It's a good thing. I don't know if you've heard about this. This is kind of making the rounds that it's going to be all over next December. I mean, someone said, I guess I'll max out my credit card then. There was a movie about this, and I think maybe the kids really wonder about this, you know, people kind of trying to scare them. Let me simply say that from the science, there's nothing to this. There's a story going around that there's a new planet, and it's going to come crashing into the Earth. There is no such planet. There's a story that the Mayan calendar runs out next December, and that's the end of the world. Well, like any calendar, it just turns over and starts again. That's not the end of things. There's a theory that the planets are going to line up, and the gravity will pull us all out of shape. They're not going to line up next year. There's a theory that the Earth's axis is going to shift next year, and the whole planet's going to turn upside down. That's not going to happen either. Who's making up all these stories? Who's trying to rewrite the future? Now, of course, it's in God's hand, and the world may end next year or the next minute, but we don't know, and those ideas are just kind of crazy. So I think kids need to be assured that science is not going to end it, but on and on the movie goes. I guess I had one last one here, and just to get real basic, gravity. Now, that holds us on the ground and keeps the Earth going around the sun. It's invisible, but it's kind of interesting, and it remains kind of a mystery. Let me just give you the latest view, because we were talking current events. Imagine that you have a trampoline, and you put a bowling ball in the middle. That's the yellow thing. See how it sinks down? And then toss a tennis ball onto this trampoline, and that might be that red line. No, it won't go in that dotted line. It'll kind of make a curve. Can you imagine on a surface like that? Well, the current view is gravity is a curving of space. And instead of a bowling ball, that's the sun, which actually makes a depression in space. And the Earth is kind of caught on the side of this hill and goes round and round. It doesn't fall in toward the middle because there's no friction, but we are just kind of caught in our orbit on this slope. And so are the other planets. Isn't that interesting? Our latest view of gravity, and they do all the math to this thing, and I think that there could well be some truth to this as we're learning more about gravity. And so everything curves space somewhat. Oh, you're saying, I don't know what you're talking about. I can imagine a trampoline, but how do you do this in 3D space? It's all mathematical, but it's almost like space can be compressed or stretched like time was. So there's some planets, and there's the sun, and even you make a curvature in space because gravity acts everywhere. Now, this is not explaining how it happens. It's just saying space needs to be curved, and maybe we're catching a little glimpse of what creation is like, what God does with gravity. One last thought with gravity, by the way, and this is a basic problem with astronomy. Astronomers don't like to talk about it, but it seems like 90% of the universe is missing. I mean, that is kind of embarrassing. Because these galaxies, like the Milky Way or Andromeda or whatever one you're looking at, they are, the way they're turning, it doesn't seem like they have enough gravity. It seems like all those stars should be flinging off to the side, that these things should disintegrate. These galaxies, they're like a merry-go-round going too fast. They should be flying to pieces, but they don't. They stay very secure. And so astronomers are saying there must be some material, some mass, that we can't see, that gravity is holding these things in place. They call it dark matter. They call it missing matter, hidden matter. They've been looking for it for years and can't find it, and they say it's 90% of everything. What a way to end our talk here with this predicament. Let me put a positive spin on it. Over in the New Testament, in the book of Colossians, there's a comment that says the Lord holds everything together, and by Him all things consist. That verse tells me that in some way, the physical world interfaces with the spirit world. maybe they can't find this hidden matter because it's not there. Maybe it's God's hand that makes gravity work and is holding these galaxies in place. I want to be careful because they keep making new discoveries, but they've really been looking for this missing matter and can't seem to find it. An interesting verse. Maybe that's the secret to the missing mass. Well, by the way, if you want to do some more work on this, one of the books out there on the table is called Astronomy in the Bible. I put that together last year, and it's got some star charts in it that you can use as the year goes by.